Today we're going to start going through how to use systems of equations to solve application problems. So today we're going to actually focus on writing systems of equations in standard form and then using them to solve a problem and interpreting what the solutions mean in context of the problem. So a few steps to follow when we're doing this. First, it's really important that you read the problem carefully and underline the important information. Define the two variables, which are going to come from what the question is asking. What do they want us to find? You're going to write two equations using the underlined information, solve the system of equations using substitution or elimination, and then check your solutions. A couple things to pay attention to is to make sure they work in both equations, and also do they make sense for the problem. If I'm asking you to find how many students fit on a bus, it doesn't make sense to have a negative answer because we can't have a negative number of students. So let's go ahead and do a couple of these. In this first problem here, the senior classes at BHS and BNHS planned separate trips to the county fair. The senior class at BHS rented and filled 6 vans and 1 bus with 118 students. BNHS rented and filled 3 vans and 2 buses with 137 students. Every van has the same number of students in it as did the buses. How many students can a van carry, and how many students can a bus carry? I'm actually going to go back and underline the important information. Okay, so senior class at BHS, so I'm going to make that purple. BHS rented and filled 6 vans and 1 bus with 118 students. Okay, North, use red, rented and filled 3 vans and 2 buses with 137 students. Common mistake here is once students underline important information, they go to define their variables and they look at BHS and North, and that's what they want to use for the variables. The variables actually come from these 2 questions at the end of the problem. How many students can a van carry? Okay, and how many students can a bus carry? Those are the 2 things we're trying to find, so those are going to be our variables. So when I'm setting this up, my first step is to go ahead and define my variables. So we're looking at the number of students per van. And I'm going to use V for that just to keep my variables matching my question. And then how many students can a bus carry? So we have B, number of students per bus. We're going to go ahead and write 2 equations now. So V is the number of students per van, B is the number of students per bus. If you go back and look at what we underlined, I kind of changed colors on purpose. One of our equations is going to come from the information for BHS, and the other one's going to come from the information for North. So when I set this up, BHS rented and filled 6 vans and 1 bus with 118 students. North rented and filled 3 vans and 2 buses with 137 students. Once I have these first few steps done, underlining the important information, defining my variables, writing the 2 equations, everything is exactly what we've been doing. So we're going to go ahead and solve this system using elimination because my variables are lined up. So I'm going to look at this, and I know that 3 goes into 6 2 times. So I'm going to multiply that second equation by 2. I get 6v plus 1b equals 118. So first equation stays the same. Second equation, I get 6v plus 4b equals 137 times 2. Don't forget to multiply it, which is 274. So equals 274. Okay, one other thing that you need to do before you can actually cancel is you need to make sure you have opposites. Notice that these don't cancel because they're both positive. So I'm going to go ahead and change my signs in one of the equations, just to the first one, and then I can add them together. So negative 6 and 6 cancel out. Negative 1 plus 4 gives me 3b. And then negative 118 plus 274 gives me 156. So we're going to divide by 3 on both sides and get 52 for an answer. Okay. Same thing we've been doing. We're going to plug this back into the original equation. So I'm going to plug it in right here for my B. I'm going to do 6v plus 1 times 52, which is 52, equals 118. I'm going to subtract 52 from both sides to get 66, and then divide by 6 on both sides. Now, when we're solving application problems, we aren't going to write our answers as ordered pairs. We kind of need to label and summarize our answers. So we are going to have 11 students per van, and 52 students per bus. Okay, so this is our answer here. We can check that by plugging those into our second equation. So if I do 3 times 52, I apologize for that, not 52. 3 times 11, so 11 students per van, plus 2 times 52 equals 137. We're going to see if that works out. So 3 times 11 is 33. 2 times 52 is 104. 104 plus 33 is 137. So it does work out. We have 11 students per van and 52 students per bus. Let's go ahead and try the next problem. This one's a little different, so we're going to read through it and then underline important information. Going down the river, a boat went 19 kilometers per hour. Going up a river, it only went 1 kilometer per hour. Okay, so important information. Down was 19, up was 1. Two things they're asking us: speed of the current and speed of the boat. Okay. What you need to remember in this situation is a current is actually, if you're riding downstream, a current's going to help speed you up. And if you're going upstream, you're working against the current, so it's going to take you a little bit longer. So I'm going to use C for the speed of current. I'm going to use B for the speed of the boat. And as you're doing this, think about what it would mean mathematically if the current is actually going to help your speed when you're going downstream. Okay, so if the current is going to help my speed when I'm going downstream, I'm going to actually add the two together. So speed of the boat plus the speed of the current is going to be 19. And when I'm going upstream, I'm working against the current, so I'm actually going to subtract. Okay, so this one's a little different. How I set it up is B plus C is 19 because the current's going to speed me up when I'm going downstream, and B minus C because the current is going to slow me down. Notice that my C's are already opposites of each other. So I already have one positive and one negative there. I can actually go ahead and add these two together. Common mistake that I see is that students will look at this and say B plus B is B. Remember, that's really 1B plus 1B, which is 2B. My C's cancel, and I get 20. 19 plus 1 is 20. So when I solve, B is 10. I'm going to go ahead and plug that back in. 10 plus C equals 19. So if I'm solving for the current, 19 minus 10 is 9. So the boat is going 10 kilometers per hour, and the current is going 9 kilometers per hour. Okay, and we can check that off to the side. If I do, in the second equation, 10 minus 9, I should get 1, which works out. Okay, so the boat is going 10 kilometers per hour. The current is going 9 kilometers per hour. We're going to do one more together, and then I'm going to have you try the last two on your own. See how you're doing with these. So example 3 says the school that Castile goes to is selling tickets to a choral performance. On the first day of ticket sales, the school sold 14 adult tickets and 1 child ticket for a total of $71. On the second day, the school took in $103 by selling 7 adult tickets and 5 child tickets. Okay, we're going to find the price of each adult ticket and child ticket. Okay, so I'm going to use A for price of adult. And I'm going to use C for the price of the child. And we're going to write 2 equations. The first equation is coming from the first day. Second equation is coming from the second day. So if the first day we had 14 adult tickets and 1 child ticket for a total of $71, my equation is 14A plus 1C equals 71. On the second day, we had 7 adult tickets and 5 child tickets for a total of $103. So once I have my 2 equations set up, know what my variables stand for, I'm going to go ahead and solve using elimination. I know that 7 goes into 14 2 times. So I'm going to go ahead and multiply by 2. So 14A plus 1C equals 71. Second equation is 14A plus 10C equals 206. Notice that my A's are not my 14s are not opposites. My A's do not cancel. I need to change my signs in one of the equations. So I'm going to go ahead and change my signs in the first equation and then add the 2 together. So if I add, negative 1 and 10 is 9. And negative 71 minus 206, plus 206 is 135. So to solve from here, I'm going to go ahead and divide by 9 on both sides. So a child ticket is $15. We're going to plug that back in to the first equation to find my adult ticket. So I'm going to do 14A plus 1 times 15, which is just 15, equals 71. We're going to subtract 15 from both sides to get 14A equals 56, and then divide by 14. So 56 divided by 14 gives me 4. Now, when we're checking these, we talked about making sure the answers make sense. I look at this one and I don't think it really makes sense because typically an adult's going to cost more than a child. This does work out. We're going to check it. But a child ticket is going to cost $15, and an adult ticket, sorry, an extra line there, is going to be $4. So if we go back and plug this into the second equation, 7 times 4 plus 5 times 15, and make sure it gives me 103. So when I multiply these out, 7 times 4 is 28. 5 times 15 is 75, and 15 plus 75 is, in fact, 103. If you have any questions, make sure you speak up before you try the guided practice problems. Otherwise, do examples 4 and 5 on your own, and let us check your answers. Make sure you label them. And once you are ready, we'll check those and make sure you get your homework before you move on. This is the last target. These are the last 3 targets we're learning before the test. So make sure you take the time to ask questions if you have them. Remember, the test is next week on Wednesday, so we only have a few more days. Have a great day.